Well, balancing these chemical equations and putting zeros out in front and then putting a 1 and all these things, it's like I wish that these cars next to me and this wind blowing wasn't scrambling my airwaves I'm pushing out of my diaphragm trying to hook up to the speaker in this camera. But lo and behold, I can't just do that by thinking of it. And so this is what would be better if the channels were less scrabbled. And in order to unscrabble channels, you can't make an entire Faraday cage and put yourself in it and push it out. You've got to understand who Maxwell was. When you're speaking about Faraday, you've got to mention Maxwell, because those two were like Sherlock Holmes and Watson. Where Faraday, he was illiterate and he didn't know math, but lo and behold, he had a great idea of what chemicals were. In the construct of electricity, his Faraday cage was as though when you were handling these electric equations, he didn't know how it fit in, he just knew that it worked. Well, then he found this guy Maxwell and he made up the equations of what a Faraday cage and electric frequency would mean. But there's one problem with Maxwell. He didn't know what was in the middle. And inside of the Faraday cage, when it gets smaller and smaller, there's a arbitrary as picking a number. So earlier when I was explaining as a Faraday cage, it's a metal device of which when you're in it, you're not going to be shocked by massive shock waves that come up. The more and more those metal curves inside of that cage are less conductive of electric, as if they were just like wood, the more and more you're going to exuberate a shock within that cage. And you know in Spencer's, that shock that had like those balls that were glass, and then they had like this electric stuff in it, and then you touch your fingers around the electric ball within it and it will connect to your fingers. The Faraday cage is like the opposite of that. And when you're mixing an opposite and equal reaction, you can interplay how much the metal is to like wood, and that would make for how much shock is it able to absorb from you. And so if you take that giant cage and you just start a prize and balancing the equation that much more accurate, so you can read more and more what's going on with the reaction to the product, that arrow, the answer of all the dangerous things that can happen are within that arrow, and you're just getting a better scope of it the more you collapse with that Faraday cage looking more and more wooden as opposed to just more and more wooden as opposed to just metal, and the electric gets more and part of you. And then the more that it's part of you, you're able to equal out what an observer's effect is. You're able to put zeros in front of each term in balancing the equation because of Heisenberg's uncertainty principle, where anything can happen. And so when you put a 1 in front of the 0, you're introducing a collapse of the wave function, and that's given a value. And from that 0 to 1 giving a value, you're able to look at the other end and of the arrow and see where. So you're just puzzling together this problem, but the more and more accurate you can look inside with the Faraday into the arrow is what the game of whack-a-mole or pin-tailed donkey is in pigeonhole theory, all within ring theory and string theory. And so I've been balancing chemical equations, and I thought that this is what the standard is with all the scientists currently. This is a collected knowledge that, yeah, you've got electric, and then you balance out the molar mass, how much of the atom weighs, and then that's, you know, like you've got and so once you balance out the electric and then the atom's weight, you're going to have yourself as accurate as possible. Well, I'm here to say I'm sorry that you've been doing it all wrong. You've got to handle it with a degree that's better than what is currently. And how fast this wind's been blowing has given me a new ideation of what a submerged is, and something as submersive as you gotta start bouncing those quarks inside of the atoms, not just the atoms, protons and what have you, to compensate for the neutrons. And then you can play the game going back out and out, smaller and smaller. But it'll just be a lot simpler if you handled it as 3 games in one. And the third game is just a theory of the first 2. The pigeonhole theory, to round up, whacking a mole, and pinning a tail on a donkey. And so the goal in all 3 of them is going to be handling each of the terms as they're just zeros and ones when you're opening up a term, and 1 is when you're evaluating it for the other side. And so that the binary coding can then be on top of the material of it to account for a better collection of the electric diodes, and then cations from there, and the other ones gives a better net.